Hello everyone, and welcome, truth seekers and stargazers. Tonight, we journey not into the romanticized cosmos of vibrant nebulae and shimmering galaxies, but into the chilling abyss. Forget the wonder, prepare for the terror. This is the dark side of space, the 5 scariest things in the universe. No sugarcoating, no Hollywood theatrics, just the cold, hard, terrifying facts. Let's dive in. 1. Vacuum decay. Our first existential horror is not an object, but a possibility so profound it makes every other fear seem trivial. Vacuum decay. Imagine, if you will, the very fabric of reality, the quantum fields that govern everything, suddenly deciding to change. Our universe currently exists in what's called a false vacuum. Think of it like a ball resting in a dip, but there's a deeper dip nearby, the true vacuum. If that ball ever gets nudged into the deeper dip, the consequences are catastrophic. According to quantum field theory, as detailed in texts like Stephen Hawking's A Brief History of Time, our vacuum state might not be the most stable configuration. If a bubble of true vacuum were to nucleate somewhere, anywhere in the cosmos, it would expand at the speed of light. This isn't a slow burn, it's an instantaneous cosmic obliteration. Every atom, every force, every fundamental constant would be rewritten. The very strong nuclear force that holds protons and neutrons together, gone. The electromagnetic force that binds electrons to nuclei, rewritten, perhaps to a state where matter simply cannot exist in any form we recognize. There would be no warning, no escape. We wouldn't even see it coming. One moment we are here, debating the mysteries of the universe. The next, our universe and everything within it is replaced by a fundamentally different, inert reality. The energy difference between the false and true vacuum states could be immense, perhaps on the order of 10 to the 38th joules per cubic meter, releasing an unimaginable burst of energy that reconfigures space-time itself. This isn't just death, it's the unmaking of existence itself. Next, we confront a phenomenon that is both incredibly distant and terrifyingly potent. Gamma-ray bursts, or GRBs. These are the most powerful explosions in the universe since the Big Bang, spewing out more energy in a few seconds than our sun will produce in its entire 10 billion-year lifespan. GRBs come in 2 main flavors, long and short. Long GRBs, lasting typically from 2 seconds to several minutes, are thought to be caused by the collapse of extremely massive stars, at least 20 to 30 times the mass of our sun, into black holes. As the core collapses, jets of matter are fired out at nearly the speed of light, producing a focused beam of gamma radiation. Short GRBs, lasting less than 2 seconds, are believed to be the result of merging neutron stars or a neutron star in a black hole, an event that ripples space-time with gravitational waves. Imagine if one of these beams, even billions of light years away, happened to be pointed directly at Earth. A GRB within, say, 6,000 light years of us would be catastrophic. The initial burst of gamma rays would strip away our ozone layer in mere seconds. This would leave all life on Earth exposed to the sun's unfiltered lethal ultraviolet radiation. The atmosphere would ionize, creating nitric oxides that would shroud the planet in a dense, toxic smog, triggering a prolonged global ice age or a mass extinction event. We're talking about a dose of radiation equivalent to 10 to the 21st joules over a few seconds, hitting a cross-section of Earth's atmosphere. It's a cosmic sniper shot, and we're in the crosshairs just waiting for the trigger to be pulled.
3. Rogue planets. Our third cosmic horror is perhaps more insidious, lurking in the silent, frigid void between the stars. Rogue planets. These are planets that have been ejected from their home star systems, adrift in the interstellar medium, forever orphaned. We're not talking about a few outliers. Astronomical estimates suggest there could be billions, perhaps trillions of these rogue planets in our galaxy alone. The Kepler Space Telescope and other surveys have identified candidates hinting at a vast, unseen population. One study, published in Nature, suggested that there could be as many as 100,000 times more rogue planets than stars in our galaxy. These worlds are typically gas giants or super-Earths, brutally cold with surface temperatures plummeting to -200 degrees Celsius or lower, driven only by residual internal heat. The terrifying aspect isn't just their desolate existence, but their potential as cosmic bowling balls. If a rogue planet, particularly one with significant mass, were to enter our solar system, its gravitational influence would be devastating. Orbits of our planets could be perturbed, leading to collisions or ejections. An Earth-sized rogue planet passing within 1 astronomical unit of Earth, roughly 150 million kilometers, could strip away our atmosphere, trigger extreme tidal forces, and potentially eject us from the solar system entirely, condemning us to a slow, agonizing freeze. It's a game of cosmic billiards with our existence as the stake, played by forces beyond our comprehension or control. 4. Supermassive black holes, or SMBHs. For our penultimate fear, we turn to the ultimate cosmic predator, supermassive black holes. Every large galaxy, including our own Milky Way, harbors one of these behemoths at its center. Our own, Sagittarius A star, weighs in at about 4.3 million times the mass of our Sun. These aren't your typical stellar mass black holes. Supermassive black holes possess event horizons millions or even billions of kilometers across. The largest ever discovered, TON 618, has a mass equivalent to 66 billion suns, with an event horizon so vast it could swallow our entire solar system 11 times over. As gas, dust, and even stars fall into their gravitational maw, they form accretion disks that heat up to billions of degrees, emitting incredible amounts of X-rays and gamma rays. Sometimes these black holes fire off colossal jets of plasma, extending hundreds of thousands of light years into space, impacting galactic evolution. If Earth were to somehow get too close to Sagittarius A star, the sheer tidal forces would rip us apart. The difference in gravitational pull between one side of the planet and the other would be immense, stretching us like spaghetti, charmingly known as spaghettification. An object falling into a black hole would be stretched thinner than a strand of DNA before reaching the event horizon. From an outside observer's perspective, time would appear to slow down infinitely as you approached the event horizon, never quite crossing it. For the falling object, however, it would cross the event horizon, and within moments, depending on the black hole's mass, be utterly destroyed. There is no escape once you cross that point of no return. The universe outside simply ceases to exist for you. The immense energy of the accretion disk, even from a distance, could sterilize entire galaxies with its radiation.
5. The Big Rip. Our final terrifying prospect isn't a singular event or object, but the ultimate end of all things, the Big Rip. For decades, scientists debated whether the universe would end in a big crunch, collapsing back on itself, or a big freeze, expanding forever until all energy is dissipated. But the discovery of dark energy, the mysterious force accelerating the universe's expansion, introduced a new, far more violent possibility. The Big Rip hypothesis, largely explored in papers by Robert Caldwell, Mark Chemiankowski, and Nevin Weinberg, suggests that if dark energy continues to strengthen and its density increases, it could eventually overcome all other fundamental forces. First, galaxies would be torn apart as the expansion overcomes their gravitational bonds. Then, individual stars and planets would be ripped from their orbits. Eventually, the expansion would become so powerful that it would overcome the electromagnetic and strong nuclear forces. Atoms themselves would be ripped apart, followed by the very fabric of space-time, leaving nothing but individual, fundamental particles instantaneously scattered into an infinite, desolate void. The timeline for this, if it occurs, is vast, billions of years into the future. But the mechanics are what truly chill to the bone. Imagine every bond, every interaction, every force that holds reality together simply ceasing to function because the very space between particles is expanding so rapidly that the forces can no longer keep up. The energy driving this expansion, currently estimated to constitute about 68% of the universe's total mass energy content, would grow to an unimaginable dominance. It's the ultimate unmaking, not just of life or planets or stars, but of existence itself, atom by atom, into nothingness. So there you have it. 5 cosmic horrors that remind us how fragile our existence is, how utterly insignificant we are in the face of the universe's terrifying power. These aren't fairy tales. They are possibilities, probabilities, and certainties based on our deepest understanding of physics. The universe is not just beautiful, it is profoundly, terrifyingly indifferent. We seek to understand, not to conquer. And in that understanding, we find not just wonder, but the deepest sense of humility, and perhaps a healthy dose of fear. Thank you for joining me on this journey into the dark. Until next time, keep looking up. But remember what might be looking back.